Introduction to organic chemistry. Families of organic compounds. Organic compounds can be grouped into families by their common structural features. We shall survey the nature of the compounds and a tour of the families in the course. This chapter deals with alkanes, compounds that contain only carbons and hydrogens, all connected exclusively by single bonds. Structures of methane, ethane, and propane, as you can see in figure 2.1. Functional groups. Functional group, collection of atoms at a site within a molecule with a common bonding pattern. The group reacts in a typical way, generally independent of the rest of the molecule. For example, double bonds in simple and complex alkenes react with bromine in the same way. As you can see in figure 3.1. Survey of functional groups. Table 3.1 lists a wide variety of functional groups that you should recognize as you learn about them. In each chapter, it will be easier to recognize them. The functional groups affect the reaction structure and physical properties of every compound in which they occur. Types of functional groups: multiple carbon single bonds. Alkenes have a double bond. Alkynes have a triple bond. Arenes have a special bond that are represented as alternating single and double bonds in a six-member ring. Functional groups with carbon singly bonded to an electronegative atom, alkyl halide, carbon bonded to halogen, alcohol C bonded to O of a hydroxyl group, ether 2 C's bonded to the same O, amine C bonded to nitrogen, thiol C bonded to the SH group, sulfide 2 carbons bonded to the same S. Bonds are polar with partial positive charge on C and partial negative charge on electronegative atom. Groups with a carbon and oxygen double bond. They're also called carbonyl groups. Aldehyde, one hydrogen bonded to C double bond O. Ketone, two C's bonded to the C double bond O. Carboxylic acid, OH, to the C double bond O. Ester single bond O bonded to the C double bond O. Amide C single bond N bonded to the CO. Acid chloride Cl bond to the C double bond O. Carbonyl C has partial positive charge. Carbonyl O has partial negative charge. Alkanes and alkane isomers. Alkanes compounds with C single bond C and C H bonds only, which are also from the no functional groups. Connecting carbons can lead to large or small molecules. The formula for an alkane with no rings in it must be CnH2n plus 2, where the number of C's is N. Alkanes are saturated with hydrogen, no more can be added. They are also called aliphatic compounds. Different ways to write butane. Alkane isomers. CH4 is methane, C2H6 is ethane, C3H8 is propane. The molecular form of an alkane with more than 3 carbons can give more than one structural isomer, C4H10. Constitutional isomers. Isomers that differ in how their atoms are arranged in chains are called constitutional isomers. Compounds other than alkanes can be constitutional isomers of one another. They must have the same molecular formula to be isomers. You have different carbon skeletons, different functional groups, different position of functional groups. As you can see, here's a table of the names of small hydrocarbons. And here's the names of larger hydrocarbons, which you're gonna take in AS level if you do take the chemistry AS level. Alkyl groups. Alkyl group move one H from an alkane as a part of structure. General abbreviation R for radical and incomplete species for the rest of the molecule. Name. You replace ane ending of alkane with a YL ending, which is gonna be like, for example, CH3 is methyl from methane, and CH3 is ethyl from ethane. You can see this in table 3.4. Types of alkyl groups. classified the connection site. See figure 3.3, a carbon at the end of a chain, primary alkyl group, a carbon in the middle of a chain, secondary alkyl group, a carbon with 3 carbons attached to it, tertiary alkyl group. You have a primary carbon is bonded to one other carbon, and you have secondary carbon is bonded to 2 other carbons, tertiary carbon is bonded to 3 other carbons, and quaternary carbon is bonded to 4 other carbons. Naming alkanes. Compounds are given systematic names by a process that uses prefix, pair, and suffix, follows specific rules named as longest possible chain. Carbons in that chain are numbered in sequence. Substituents are numbered at their point of attachment. Compound name is one word, a word for German style. Complex substituents are named as compounds. Would be see specific examples in the text here, as you can see. Properties of alkanes called paraffins, low affinity compounds. Because they do not react with most chemicals, they will burn in flame, producing carbon dioxide, water, and heat. They react with Cl2 in the presence of light to replace H's with Cl's, not controlled. Physical properties, boiling points and melting points increase as size of alkane increases. Forces between molecules of temporary dispersion are weak. As you can see here, the boiling point is way higher than the melting point. Cycloalkanes. Cycloalkanes are alkanes that have carbon atoms that form a ring called alicylic compounds. Simple cycloalkanes rings of CH2 units, CH2N or CnH2N. Structure is shown as a regular polygon with the number of vertices equal to the number of C's as a projection of the actual structure. As you can see here, cyclopropane, cyclobutane, and cyclopentane, and cyclohexane, and you can go on. Complex cycloalkanes. Naturally occurring materials contain cycloalkane structures. Example, terephthalic acid, cyclopropane, and prostaglandins, cyclopentane, steroids, and cyclohexanes, and a cyclopentane. Properties of cycloalkanes. Melting points are affected by the shapes and the way that crystals pack, so they do not change uniformly. Naming cycloalkanes. Count the number of carbon atoms in the ring and the number in the largest substituent chain. If the number of carbon atoms in the ring is equal to or greater than the number of the substituent, the compound is named as an alkyl substitute cycloalkane. For an alkyl or halo substitute cycloalkane, start at the point of attachment as C1 and number the substituents on the ring so that the second substituent has as low numbers as possible. Number the substituents and write their name. See the text for more details down there. Cis-Trans isomers in the cycloalkanes. Rotation about carbon's single bonds in cycloalkanes is limited by the ring structure. Rings have 2 faces and substituents are labeled as to their relative facial positions. There are 2 different 1,2 dimethyl cyclopropane isomers, one with the 2 methyls on the same side, CIS of the ring, and one of the methyls on opposite sides as trans. Stereoisomers, compounds with atoms connected to the same order but which differ in 3-dimensional orientation, are stereoisomers. The terms CIS and trans should be used to specify stereoisomeric ring structures. Recall that constitutional isomers have atoms connected in different order. Constitutional isomers, which are different connections between atoms. Stereoisomers, same connections but different 3-dimensional geometry. Thank you. I hope you understood.